Hey everybody, welcome back. This is Tech Junior Tutorials. I'm Lee Warwick Jr. and we are doing Advent of Code. So today is day 5. I was actually able to crack this one, part 1 and 2 this morning, which I really surprised myself, especially after yesterday and the day before. Those problems really got my goat. I got super frustrated. I was pretty blown away by the difficulty of those ones. Today, we're actually building on day 2. So working again with the Encode program is actually a little bit more straightforward, even though there was a whole lot to the instructions. So let's jump into it and take a look. So back on the Advent of Code website, back down to day 5. Sunny with a chance of asteroids. So right away they tell you that we're going to go back to the Encode program that we built previously, except we are adding some stuff onto it. So the first thing we're going to do is add a couple of instructions, which is not too terrible. And then the second thing we're going to do is add some different parameter modes, which was a really tough thing to digest early in the morning. If we look at the existing Encode problem, just for a quick refresher, if you don't remember this one at all, go back to day 2's videos and check that out. But just a basic overview, the Encode program takes an array of numbers and then performs operations on them. So for this example, it looks at this first index and says, oh, that's a 1. That means that we're going to do an addition problem, and it looks ahead for the next 2 arguments and says, I'm going to look in position 0 and add those together. So position 0 is 1, position 0 again is 1. Add those together and write them to position 3, which 0, 1, 2, 3 would be this spot, so this would become 2. And then when it hits 99, it would exit. So it would, once it does this original operation, it always moved ahead 4 places. So the index at 0 went to 1, 2, 3, 4, and then it does the next operation. So that operation 99 means exit or halt, and you're done. Now on day 5, instead of having addition and multiplication, gosh, excuse me. On day 5, instead of having addition and multiplication, we're doing 2 more opcodes. So we're doing take an input with a 3 and do some output with a 4. So here's an example. This example says we're going to take the input and write it to position 0, which would be the 3. And then we're going to do whatever our output operation is. And output whatever is at that address, which would be 0. So that would be the 3. And then halt. So that part was not too terrible. But the second part is where things get interesting. So there's a whole lot of text to this example, a massive amount. But basically the gist of it is in this snippet here. They say that for your opcode now, you can get as many as, I guess technically 5, but it only comes out to be 4. You can get as many as 4 digits in your opcode. So now you look at the first 2 for the operation. So this would be multiplication just like before. But now we need to look going from right to left at the modes of our parameters. So position C, mode of the first parameter, that's going to be 0, which is position mode, which is just the way that it worked before. Go to that index, look up the value. But now we have immediate mode, which means, so like B position or param 2, that means that whatever param 2 is at that spot is no longer an index. It's going to be whatever that thing is, the value of it. So looking at this example up here, we've got an opcode of 2, which says we're going to multiply 2 things. And then position or param 0, I'm sorry, param 1 is going to be 0, meaning we're going to go look up the value. So we're looking up the value that's at position 4. And then for 1, that's immediate, so we're going to use the value 3. And then 4, they don't give you the opcode, I mean the mode, but it's implied that it's a 0. You just don't see it because of this integer. It doesn't have a leading 0. So they go on to say that parameters that an instruction writes to will never be in immediate mode. So this third parameter in the addition and multiplication tells you where you're going to write a value. So they say that that will always be immediate mode. I mean, they'll never be immediate. Always be position. So you don't have to worry about looking at a value there because it's where you're going to write the answer. So curious enough, going off of that information, these other 2 opcodes also play by those rules. So you can get a 104 for a code, which I don't know if they actually give you that example in here. I don't believe they do. So if this value was 104, you would just, so that would tell you if that's a 4 that you're going to output whatever the parameter is, and then the 1 would tell you that it's in immediate mode. So if this was 104, you would look at that value and say, I'm going to output the value 4, like immediately. And then you would jump 2 places to the next opcode. So a whole lot of stuff going on in this one. There's also the other kind of ambiguity, which is the inputs and outputs. So they don't actually tell you what the input and the output is. It just says that these instructions will come with documentation that explains what should be connected to the input and output. So these aren't your inputs or outputs. These are just like where you're reading or writing to. Reading from or writing to. So you don't really know what the input or output is until you get like all the way down to the bottom. And then it says somewhere in here, okay. So it's going to request from the user the ID of the system to test by running an input instruction. So give it a 1. So they're telling you that you need to pass it an input of 1. And then that value is what the program is going to use when it hits operation 3. And then the output, they don't really ever tell you what it is. So I think you could use like a console log or a print statement or something, which is what I ended up doing. But that is ambiguous as well. So it could be a callback, it could be, whatever. So they don't really tell you. But then the final piece to this is that you're going to run some kind of diagnostic thing, and it's going to tell you that your output should all be 0, except for the last one, which is the diagnostic code. So they're doing some kind of like operations on all these inputs, and it's going to spit out a diagnostic code at the end, but it tells you, where is it at? It will perform a series of tests confirming that various parts of the computer function correctly. So for each test, it will run an output instruction indicating how far the result of the test was from the expected value, where 0 means that it was successful. So it's basically they gave you like a test to run on your own program, which was kind of awesome because the previous challenges for this were not like that at all. They would give you like some dummy inputs like this and say like, okay, this is going to give you a result that's this. Here's a simple program for you or something like that. Here's an input and this should pass or fail. Here they're actually like, your input is your like test code at the same time, which was amazing. That made it a lot easier because basically if it ran with all zeros, you know that you have the answer. Or you've done something hilariously wrong. So we'll go ahead and look at the code for this real quick. So I started with day 2's code, and for day 2, I needed to do some refactoring from this for a couple of different reasons. So first, I am looping over a whole bunch of stuff. I think these are my instructions from day 2 or something like that, but I didn't need that. I deleted that. I deleted the set encode function. So basically my encode function was the main piece that I needed for today. And because on day 2, they tell you have to change 2 places in your input before running the program, I just wrote a higher order function that did that for me. So it took in 2 parameters and then created a new input, did this test, and then returned this encode function. So whatever that returns gets returned from this higher function, which then gives me the output that I want. So it prints the end of it. Oh, this was part 2 of day 2, if I remember correctly. Any case, so what had to change about this encode function was that, first of all, I was inside this function looking for position 0 to be returned whenever it halted. That's no longer the case. Whenever your program ends in today's, they do not tell you that you're supposed to return position 0. They tell you that your output is supposed to be configurable, right? So I went ahead and removed that. The other problem was that I am in this program always doing a lookup with whatever the parameters are to basically jump into that array and find whatever my input is. So if I had a program that was like 1, 2, 3, I don't know, 5, 99. Let me think. 0, 1, 2, 3, 4, 5. So this would say do addition, look up the value at 2, so 0, 1, 2, that would be 3. Look up the value at 3, should be 5. Add those together and then put them in position 5, should be the 0, and then halt and return whatever was at position 0. So when this runs, it would return position 0, which is 1. That's no longer what we want. Also, if this was now in day 5, let's say a 0, 0, 1, this would still be addition, but now for our second parameter, which would be the 3, now we're using immediate mode, meaning that the value of that is 3. Whereas here we're doing lookup mode, where the value would also be 3. So maybe that's a bad example, but hopefully you get the idea. So that had to be refactored. I had to clean this up a lot. So I'm not going to live code this because I think it'll take too long. I'm just going to look at part 1's solution. So if we drop down to way down here, I've got my encode program that's been updated. So now I am giving it an input value. I'm giving it the index to start at, like before, but I'm also giving it an output method. And I just gave that a default of print in Python. So if I wanted to override it later, I could, but for right now, it just prints it to the console. Then I do all of that fancy stuff with like modes and whatnot in a different function. Basically pass my program and my index into, program being the array of inputs, program and index into that function, does its thing, gives me back whatever my code is and all my params. And then if I'm at 99, I just stop. If I'm at 1, just like before, we add the params together and write to 3, and then jump up by 4. And then recursively call the program again. So I think that doing it this way greatly simplified the logic for the actual encode program, as opposed to like deciphering what the input mode is and all this stuff. Here it's very easy to look at this and go like, okay, 2 multiplies them. 3 just writes my input value to wherever it's specified on param 1. Then we jump up to the next thing. If it's 4, we just output whatever param 1 is. So it really simplifies what's going on. And then down here, whenever I actually call this thing, I don't know if VS Code will, yeah, there we go. When we call this thing, we just give it the input, or I'm sorry, the array of numbers, and then whatever the input value is. So the instructions tell you to give it 1. So there we go, we just give it 1. And then if we want to run this real quick, you'll see that when you run it, you get all zeros and then your code. So if you got a number that wasn't a 0 here, that lets you know that your logic is off somewhere. So the real tough part of this was actually parsing the modes and whatnot. So that is up here in this get inputs function. So also real quick, the logic here for getting my inputs is the same as previously. So I just read from a text file. I do a quick map to convert everything in that array or list. I'm sorry, we're in Python. Everything in that list into a number. And then I convert it. Well, the map function turns it into an iterable. The list constructor turns it into a list. And so then I get a list of numbers, which is easier to work with. In any case, so this get inputs thing function is where all the magic happens. So basically, I've got kind of a increasing complexity as we go on. Our opcode is 99. I just return, and I do some unpacking here. So I'm returning I think this is a tuple, returning a tuple with the opcode and then just a bunch of nuns because they don't get used if it's a 99. If we're a 3, we know that we don't care about read or sorry, not read or write. It's immediate or position mode. We know that it's always going to be position mode. So again, just go ahead and return the code, the parameter, and none. Then things get interesting. So somebody suggested some different solutions for this. Parsing of the opcode, which again, just to refresh your memory, is this number here. So we need to parse this for whatever the operation is, these two last numbers, and then we need to count from right to left, param1, param2, which is that one, and say, okay, that's immediate mode, write it to position 0. So what we do here is we say, if the opcode is less than 3, that means that we didn't get any modes. And it's just everything is in position mode. So I just created a string of 00 to indicate like position mode. If that's not the case, then we're going to take those last 2 digits, and so we do like a backward slice with Python, which is pretty cool. And then we turn that into an int, and I'm going to call that parsed opcode. Then we're going to take that opcode again. We're going to say if the length is 3, that means they only gave us 1 code. So if you look back here, they don't actually show you this, I don't think, in the example. Yeah, I don't. Well, let's pretend that this is one of our inputs. So let's say that this 104 is an opcode. That tells you that, well, actually, that's not really a good example. We would want like a 102 or a 101. So let's say we were working with 101 for our opcode. That's a length of 3. But a 1 has 3 parameters, and they've only given us 1 mode. So we need to basically change our number into a 00. So we can say like, okay, 1 is immediate mode, and then we've got position mode, and then I don't even really worry about that that third parameter's mode because it's always going to be position mode. So basically, if it's 3, I give it a leading 0, and that would give me whether it's a 1 or a 0 and a 0. So the output of this would be 1, 0, or 0, 0. And then if the code is 4, I'm going to do another backwards, or I'm sorry, this is not a backwards slice, but this is a slice of from the beginning to 2 positions from the end. So if we've got 1101, this is telling it to slice from there to there. So it's going to cut the 11 off of that. And we'll get rid of the actual opcode itself. So we grab that, and then because we're moving from right to left, but our arrays and lists and computer science and everything goes from left to right, I just call a reverse on it. Python doesn't have I think it does have a reverse method, actually, but to reverse a string in Python, you use the slice syntax again, except you just give it a -1 step. Oops. So it's like iterating that slice from the end to the beginning, and that gives you a reverse of the string. So with that done, now I can create my return values. So if the opcode is less than 3, that's addition or multiplication. That means we're going to have 3 parameters. So I just grab param 1, 2, and 3, and then I say, like, if the mode is 0, meaning it is position mode, then I just return it. If it's in immediate mode, I do the lookup and get the value and then return that. Same thing for param 2, and then I just return all of them. And then if it is a 4, because remember 3, like we've already handled that test case basically, way up here at the top. If it's a 4, then I just grab the next parameter, decide what mode that's in, and return that. And so if we do that, and we run it, like I said, it'll go output a whole bunch of zeros if everything worked, and then give you the answer. The interesting part now is when you jump over to part 2, they're like, hey, that's great. Using the same inputs, we're going to add more functionality and get a different output, which is kind of insane. But basically, you add 4 more opcodes. So 5 does jump if true, 6 jump if false, which doesn't really make a whole lot of sense when you think about it. 7 is less than, 8 is equals. Add all of those in, and now change your input to 5, and it's going to say what's the new code that it outputs. So basically, without diving too in depth with these codes, we're going to look at the actual solution. So get inputs is going to be almost the same as before, except I've had to add a couple of cases. So now this jump if true is going to take 2 parameters instead of 3. Same thing with jump if false. And now 7 and 8 are going to take 1 parameter, just like opcode 3 and 4. So stay with me. I modified my int code program. So we've still got 1, 2, 3, and 4, but now we've got 5, and that says if param1 is not 0, the index is going to be param2. Otherwise, we're just going to jump ahead 3 places and go to the next instruction. Remember, this is 3 because we've got 2 parameters and not 3. So it's not jump ahead 4 like addition or multiplication. And then for opcode 6, if it is equal 0, so that's the false, jump if false, we're going to again set the index to that second param. And then for 7 and 8, 7 does a less than, so if param1 is less than param2, write to param3, works just like addition and multiplication. And then equals, same thing, param1, param2, if they're equal, write to param3. Or I'm sorry, if it's less than, you're going to write 1 to param3 for true, otherwise false, which is a 0. And then for 8, if param1 is equal to param2, that's true, write a 1, otherwise write a false, and then jump ahead 4. So going back up here, maybe now it makes a little bit more sense. Basically, the cases where you're less than 3 or greater than 6, that's 3 inputs. 5 or 6 use 2 inputs. 4 uses 1 input or parameter. So that's why I've refactored this. Another thing that I changed was I changed this from a recursive problem to a while loop. It did work recursively, so we can go ahead and run this real quick. So it gives me the output that I wanted, which was, I don't know, the 6,900,000. So we got down here. But interestingly enough, if you give it an output like this, basically this creates a loop that is 1,000 iterations long. Basically, if you do this recursively in Python, Python will blow up, more or less. So if we run Python and we say like import system sys.get recursion limit, it tells you can only do 1,000 recursive calls. So if you were to run this program, which does it's basically a loop. So it says do some addition. 0 is a position lookup. No, 0 is, gosh, okay. So we're not looking at that 0, we're looking at that. So 1 is, I think, immediate. So we're doing -1. Go to position 8. So remember that leading 0 is hidden. So go to that 1,000 and add -1. Write that to position 8, which is the 1,000. And then it does a 5. And it says 5 is the jump if true. Way down here. So it says if param1 is not equal to param2. So param1 is 8, that 1,000. And that's going to be a lookup. Then you have an immediate mode telling you that if position 8 is not 0, go back to gosh, how's this work? Go back to position 0, I think. It's a little bit confusing. So basically, don't change the index. If param1 is not equal to param2, then index is equal to param2. And param2 is 0. So it says if 1,000 is not 0, go to 0. So it does that subtraction again. So basically it counts down from 1,000 to nothing, or to 0, and then terminates. I'm sorry. And then it, this was provided to me by somebody else, but basically then it does this immediate output where it outputs 1,000, or it would be a 0 in this case, after the loop is finished, and then it terminates. So if you run this, it gives you 0, but that just that just iterated 1,000 times. And if you do that with recursion, it blows up. So, gosh, sorry. So basically, I refactored it to be a while loop, which was pretty easy because I was already keeping track of my index by just passing it into a new function call. So I just had to remove all those return statements, tack a while greater than or equal to 0 at the top, and I was good to go. So yeah, that is it for day 5. Day 5 was, I don't want to say it was easier because it depended on day 2. So like I saw on Reddit, one guy did it on a piece of paper. I feel really bad for that guy if he tried to do day 5 on a piece of paper. That would be kind of rough. There was quite a lot of inputs to look at. I don't know if I pull it up real quick. So a whole lot of inputs. This would take you a long time to do on paper. But anyway, day 5 wasn't that bad. If you sat down and really read the instructions and read them over and over again, I probably spent about an hour this morning when I first got up just reading the instructions over and over before actually writing the code, which I think helped me out on this one. And then I think I got lucky in my implementation of day 2. I didn't muck around with the actual int code too much, so I was able to reuse a lot of that for today's solution and get it pretty fast. So it went pretty well. I was really happy to get those 2 gold stars first thing in the morning. That was a good confidence boost after yesterday, where I was like ready to flip my desk. So that's all I've got for today. Like, comment, subscribe, all that good stuff. Let me know how you're doing in Advent of Code. And hopefully I have time to pick up tomorrow's solution. If not, good luck to you out there. All right, bye.